In this video, we're going to talk about the rules of exponents. The rules of exponents are also known as the laws of exponents and the properties of exponents. So depending on how your teacher has explained them to you, these are the rules. The first one is any number to the 0 power is equal to 1. Okay, so x to the 0 power is equal to 1 as long as x does not equal 0. What does that look like in terms of problems? Sometimes you're going to have a problem like 4x squared y cubed all to the 0 power. This is just equal to 1. If you have something like 4 times x squared y cubed to the 0 power, then notice the 0 power applies to everything inside of the parentheses, and so technically you're left with 4 times 1, so this answer is equal to 4. Sometimes you have something like 4x y to the 0 z to the 3rd power. Well, I'm going to be left with 4x. Y to the 0 power is just 1. So basically it just becomes 4x z cubed. So that's how some of these problems look. The second rule says that when you multiply, if you have the same base and you are multiplying, you're going to add the powers. So this could be x to the 3rd power times x to the 2nd power. This is equal to x to the 5th power. Or I could have y to the 4th power times y to the 7th power. You're multiplying, you have the same base, you're going to add the powers. This is y to the 11th power. You have to be very careful not to confuse this with the next rule. The next rule says when you have parentheses and you only have one base, x is the base, and it's raised to a power, then you multiply the powers. So how would this look differently? If I had x cubed squared, notice I don't have two x's like I did before. I have x cubed squared. Then here I would multiply the exponents. This is equal to x to the 6th power. And you might be wondering why? Well, because x cubed squared means that in reality, I have x cubed times itself. And so x cubed times x cubed is x to the 6th power. So that's why it works. Same thing would happen if instead of having y to the 4th times y to the 7th, I would have y to the 4th to the 7th power. Now I have a power to a power, so this becomes y to the 28th power. So notice how different these two problems are. Don't just guide yourself by parentheses because the way I wrote it the first time, here I have parentheses, but the key is that the y is there twice. Whereas right now, yes, I have parentheses, the y is only there once. It is a power to a power. And that is when you're going to multiply the exponents. The next rule says when you have parentheses and you have an exponent on the outside, that exponent belongs to everything inside of the parentheses. So if I have x to the 4th power, y to the 5th, and everything is squared, that means that that exponent is going to have to get distributed to everything inside of those parentheses. So this would make this x to the 8th, y to the 10th. Be careful, however, when you have a number inside of the parentheses, because when you distribute that power, it doesn't mean 3 times 2, it means 3 squared, which is 9. So 9x to the 8th, y to the 10th. So be very careful when you have that number in front. The next rule is what happens when we are dividing. When you divide and you have the bases there twice, then you're going to subtract the exponents. An example is y to the 12th power divided by y to the 4th power. This means y to the 12th minus 4, which is just y to the 8th power. Okay, so when you are dividing, then you're going to subtract the exponents. Sometimes you'll get a problem that looks like this, x cubed y to the 10th over x squared y to the 24th. And one of the ways that you can do this problem is to find the difference of the exponents, as long as obviously you have the same variable, and then put the answer wherever you have the highest power. Meaning right now for the x's, I have one that's x cubed, one that is x squared. The difference is 1. 3 minus 2 is 1. Because x cubed is bigger on top, I'm going to go ahead and keep my answer on top. When I look at the y's, it's y to the 10th, y to the 24th. Well, the difference is 14. Because y to the 24th is bigger in the denominator, I'm going to write y to the 14th in the denominator. You might be asking yourself, why does this work? Why don't I just use the subtraction we just learned from the property? No problem. Let me show you what happens when you do that. So this is going to equal x3 minus 2, and then y 10 minus 24. So 3 minus 2 is 1, and then 10 minus 24 is negative 14. And that's going to bring me to the next property, which says that when you have a negative exponent, to get rid of the negative exponent, you have to flip it. You have to do the reciprocal. So right now, in order for me to make that negative 14 positive, I'm going to have to make it not stay at the top, but actually come down to the bottom. And that's how I got to be exactly in the same place as before. So that's my same answer. And then finally, the last one is also very intuitive. If I have something like a over b to the third power, this means go ahead and distribute the exponent to both the numerator and denominator. So you ready to try some problems? Let's go for it. Directions. Simplify each expression. Use only positive exponents. Okay, number 1. 2x cubed times 4x squared. The numbers are being multiplied. 2 times 4 is 8. Now come the rules of exponents. When you are multiplying, notice how we have x cubed and x squared. They are exactly the same variable, the same base. So the rule says when you multiply, you're going to add the powers. So here, because I have the same base, x cubed, x squared, this becomes x to the 5th power. In number 2, we are dividing. 4 divided by 2 is 2. The rules of exponents say when you have the same base and you are dividing, you're going to subtract. Notice, however, here I have a to the 8th and x to the 3rd. They are not the same variable. I did that on purpose, I know. But they are not the same variable, so that's how the answer would stay. If, however, the problem says 4a to the 8th over 2a to the 3rd, where I do have the same variable, they're both a's, 4 divided by 2 is still 2, and then because you are dividing, and in that case you do have the same base, 8 minus 3 is just 5. So the answer will be 2a to the 5th power. But always make sure that you have the same variable, otherwise you cannot apply the rules of exponents. In number 3, remember we talked about the parentheses, and this power on the outside is going to get distributed to everything inside of the parentheses. So that means 7 squared is 49. X squared squared is x to the 4th. A power to a power, you multiply the powers. Y to the 4th squared is y to the 8th power. So that's my final answer. In number 4, the entire numerator is being raised to the 0 power. Anything to the 0 power is 1. So the answer is 1 over 4a cubed b, because there's nothing else I can do in the denominator. In number 5, I'm going to multiply. Negative 5 times 3 is negative 15. R squared times r to the 1 is r to the 3rd power. S to the 4th times s squared is s to the 6th power. Be careful with your s's so that they don't look like 5s. In number 6, I have a negative exponent on the outside, and I want to immediately take care of that negative to avoid any problems. So the way I'm going to do that is to basically rewrite the problem. Since everything is in parentheses, the negative applies to the entire problem. So I'm going to write 1 over parentheses 6x to the 4th, y to the 10th squared. So by flipping the problem around completely, I've gotten rid of that negative exponent, and now I can finish the problem. So this becomes 1 over 36 x to the 8th, y to the 20th power. And that's my final answer. Hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.